तो मैं यहाँ 2 बातों का ध्यान रखना है। इसने इंक्रीजिंग ऑर्डर डिक्रीजिंग ऑर्डर नहीं पूछा, इसने पूछा सीक्वेंस किसकी होगी, यानी सबसे पहले किसने डिपॉजिट होना है और सबसे बाद में किसने डिपॉजिट होना है। यहाँ पे इन्होंने एक काम करी है कि ये वर्ड लिख रखा है रिडक्शन पोटेंशियल, और ये अपना रेफरेंस है, ये अपना रेफरेंस है। इस वाले केस में एक छोटी सी प्रॉब्लम क्या है, इस वाली केस में छोटी सी प्रॉब्लम क्या है कि ये जो फॉर्मेट दे रखा है ये उतना सही नहीं है, लेकिन इसे चेंज क्यों नहीं करा, क्योंकि ये PYQ है, लेकिन फिर भी इसके ऊपर तो सॉल्व कर सकते हैं, रिडक्शन पोटेंशियल के ऊपर। तो इन्होंने रिडक्शन पोटेंशियल बना रखी है और फिर कह रहे हैं कि सबसे आसानी से सबसे पहले कौन सा रिड्यूस होगा, तो इसकी नेगेटिव रिडक्शन पोटेंशियल है, ये तो होगा ही नहीं, तो Mn को हमें बाहर कर देना है। तो जिन ऑप्शंस में Mg है, जिन ऑप्शंस में Mg है वो रेस के बाहर हो गए। अब इनमें सबसे बड़ी वैल्यू कौन सी है, 0.8, फिर 0.7, फिर 0.3। सबसे पहले कॉपर सिल्वर ने डिपॉजिट होना है, फिर Hg और फिर कॉपर। आंसर है ऑप्शन नंबर 3, आंसर है ऑप्शन नंबर 3। इस वाली केस में इन्होंने जो रिप्रेजेंटेशन करी है ये प्रॉपर नहीं है, इस वाली केस में थोड़ी कन्फ्यूजन क्रिएट हो सकती है, लेकिन जो डाटा दे रखा है और जिस सीक्वेंस में दे रखा है उससे हम इसे सॉल्व कर सकते हैं। ओनली वन नॉन जीरो वैल्यू शुड बी देयर फॉर द ऑक्सीडेशन नंबर, ओनली वन नॉन जीरो वैल्यू। So if I start with the oxygen, it's a -2, -1 and -1/2. This -1/2 is for superoxide, this is for peroxide, and this one is for normal oxide. This one is for the normal oxide. So this cannot be the right answer. In case of B or it can show +1, +3, +5, +7, and in between it can show the even oxidation number also. So this came out from the race. Ag mostly show +1 state, but it has some salt in the +2 state also. For example, AgSO4 is there, AgCrO4 is there, AgF2 is there, and it's a AgO. Although very rare, but of course they can show. So this also came out. In the case of sodium, it can show only +1 state. In case of fluorine, it shows -1, but in case of HOF, it shows +1. Although this part has not been discussed in the NCERT, so we can give the rebate for the fluorine also. In the case of HOF, basically it exists as a positive charge, and why it is? It's a OF negative charge. We know that oxygen is having -2, so -2 plus X is going to be -1, so X is going to be +1. This is the logic. Being an acid, it has to generate H positive, otherwise it will act as a, if I break it like F negative and OH negative, then I should say that this one is acting as a base, this one is a base, but we know that it's a acid. That's why it should have a tendency to show +1, but in the NCERT this part has not been mentioned. In case of arsenic, Ti and Si, in case of Si, it can show +4 and -4 both. But in the case of arsenic, it's a nitrogen family, so it can show +3 and +5 both. Ti, it can show +1, it can show +3, it can show +1 and it can show +3. It can show +2 also, but that is going to be less stable. Up to +4, it can be up to +4. So most precise answer should be only one. It's a sodium only. But because NCERT has not covered this HOF issue, so we can say that the answer is option number 2. These two can show, this two are having tendency to show only one non-zero oxidation state. This one is a nice way to project a simple question in a hardest manner. It's a very simple question. What they have told? This is the arrangement. They are telling X belongs to 16th group and 3rd period. We know that 16th group and 3rd period, it means it should be 3s2, 3p4. It means atomic number 16 and it's a sulfur. From here I can decode that it's a sulfur. If it is sulfur, then this can be written as sulfur. This is oxygen. This one is phosphorus and this one is chlorine. Chlorine can be written as Y, Z. Chlorine can be written as Z. Oxygen can be written as Y. P can be written as W. And S can be written as X. Maximum electronegativity Y. Y is the maximum electronegative. Of course, Y is having maximum electronegativity among the given 4 options. So this is the right statement. Maximum catenation property. Phosphorus can form P4 whereas sulfur can form S8. So this is the second. This statement is also correct statement. Maximum electron negativity, maximum electron affinity Z. Chlorine is having the highest electron affinity in the periodic table. So this is these 3 are the correct statement. Y exhibit variable valency. No, Y can show only 2 valency. Y can form only 2 bond. It doesn't have any D subshell, so it cannot show the variable valency. So the answer is 4th is the incorrect statement. 4th is the incorrect statement. 4 statements are there and they have been correlated with the 4 different options. In all such cases, you need to write the atomic number and name of the element. Name of the element. It's a atomic number 30. This is 34 plus 35. This is known as rubidium. You will see that this is 4F14, 6D1, 7S2. 14, S2 and D1. It means it's the last element of the 5D series. Actinides, last element of the actinides. So it's a lutetium 103. It's a 30 plus 5, 35. 35 means it is going to be bromine. It's a 28, 26. This is going to iron. So we know that 4 different elements are there. It's a rubidium, it's a lutetium, bromine and iron. So the first part is, first shows the variable oxidation state. Rubidium shows only +1. So this one is the incorrect statement. The 2 is the D block element. This is the F block element. More precisely, it's a 5F, actinoids. This is actinoids, not the D block element, so this is incorrect, factually incorrect. The compound formed between 1 and 3. So 1 and 3 will generate RbBr. This is going to be ionic in the nature. What is written here? It's a covalent, so this is going to be incorrect statement. This is going to be incorrect statement. 4th will show single oxidation state. Fe can show +2 and +3, which is very common. It can show +4 and +6 also. Although not very common, but common. But it exists. So when the question is there, only it can show. We can see that it can show 4 different oxidation state. Out of these 4, 2 is very common. So the right answer is option number 4. All statements are incorrect. So here we need to find out the set of molecules or set of the atoms which are having the high electron enthalpy, but zero ionization enthalpy. It's a very rare, very rare combination. Now we need to think whether this type of combination exists or it's a hypothetical. Unfortunately or fortunately, in the periodic table there is no element which is having the zero ionization energy. With zero ionization energy there is no element. So the right answer is 4th. Opposite can be true. If the opposite options are given, it can be true. In that case we can go for, if the zero ionization energy means low electron affinity and high IE. If this is the combination opposite to this, in that case we can go for group 15. Nitrogen is having very high ionization energy, but at the same time they are having very low electron affinity. Another group is also there, that is group 2. magnesium, beryllium, calcium. They are having S2 configuration, so electron affinity is very, very less. But as far as the question is concerned, it's a very funny type of the question, because such type of element doesn't exist till today in the periodic table. So out of the 4 options, we need to find which of the following is not the endothermic. Means we need to find the exothermic. We need to find the exothermic part. It's not endothermic. So obviously the opposite of endothermic is the exothermic. Here argon is accepting 1 electron. Argon is accepting 1 electron. Argon itself is having completely filled d subshell, completely filled shells PC. So when we add the electron to the half filled, addition of electron to half filled completely filled. Completely filled subshell cannot be exothermic. Cannot be exothermic. So basically it's a endothermic. So this one is the endothermic because it's endothermic because argon is having completely filled d subshell. We are removing the electron. This one is the IE. This one is the electron affinity. Electron affinity of inert gas. Electron affinity of inert gas is always endothermic in the nature. Removal of electron from any atom. It's a endothermic process. IE is always endothermic process, whether it's a IE1 or IE2. Oxygen negative and negative. So negative charge, negative and negative, they cannot attract. So once again this one is endothermic because repulsion is there. So this cannot be the endothermic. And this one is the part hydrogen electron affinity. It's a EA1, and we know that EA1 is always exothermic. In the nature. So answer is option number 3. Now this can be solved within 2 minutes if you know what the formula should be used and what is the meaning of all these things. This is the concentration cell. This is a concentration cell, and we know this is a concentration cell which uses the same electrolyte of different concentration. Same electrolyte will be there, but the different concentration will be used. Then how to decide which is going to be electrolyte, which is going to be electrode, cathode or anode, which will act as a cathode, which will act as an anode. So we can have several type of the, we can have 4 or 5 type of the question. Number 1, buffer generates EMF. Does buffer generates EMF? If yes, then how? And how to decide which is going to act as a cathode and which is going to act as an anode? And it's very interesting that if you write 0.059 by 2 in this case, this is going to be the wrong answer. But if you write 0.059 by 1, this is going to be the right answer. And which formula should be used? Then of course formula is only one. It's a E cell is equal to E cathode minus E anode. But how to decide which will act as a cathode and which will act as a anode? Because both are having similar concentration, same constant. Both are having same electrode, but the different concentrations. So lower concentration will act as a anode, and higher concentration will act as a cathode. Higher concentration will act as a cathode. But why? Suppose higher concentration of H positive is there, it is having tendency to form H2 positive. Whereas if H positive is lesser, then H2 will form hydrogen. And because H2 to hydrogen, it is oxidation, and H positive to H2, it is going to be reduction. It's a reduction in this case and it's a oxidation in this case. So it's very easy to identify that electrode with the lower concentration will act as a anode, whereas higher concentration will act as a cathode. Now why one electron has been used? Because we are using the half cell only. We are using the half cell only. Oxidation half, reduction half. We are not using the entire, means we are not going for the entire complete equation. Half cell for one compartment, half cell reaction for another compartment. So in place of 2, we need to take the 1. Can buffer generate EMF? Answer is yes. Not very frequently, but it can, like in this case. But buffer is having this formula. pH is equal to pKa plus log A negative by HA. How this is going to generate the E cell? How this is going to generate the E cell? What is the correlation between these two formula? And answer is very simple. Answer is very simple, that they are related as from pH we can find the concentration of H positive, and we can use the formula 0.059 log H positive to find the E cell. Of course, this is for one compartment only. So E cathode or E node. So should I start from here? We got the answer for all. We got the answer for all queries. Number 1, can it act as a, can buffer solution provide the EMF? Answer is yes. In some time we can. Which will act as a cathode, which will act as a anode. Lower concentration will act as a anode. Higher concentration will act as a cathode. Okay. How many electron has to be considered? Half of the total, or we need to go by the state compartment wise equation. So in one compartment it's a 1 electron, so only 1 electron has to be considered. Then formula is same. It's a E cell, E cathode minus E anode, and E can be correlated as pH. So from pH we are going to find the H positive. We will put the value here to find the E cell, or it's a E anode or E cathode. Start from here. So pH is equal to pKa plus log H negative by H, A negative by, it's a A negative by HA. So pK is 4 for all, plus log A negative is going to be 1, whereas HA is 0.1. So this is 4 plus log 10, which is equal to 4 plus 5, 4 plus 1, that is going to be 5. It means H positive is 10 raised to power minus 5. If it is 10 raised to power minus 5, what can be the E cell? Or this is acting as a anode, so what will be the E anode? It's a 0.059 by 1 into log 10 raised to power minus 5. We can ignore the E naught cell, because E naught cell for the hydrogen is going to be 0. E naught cell for the hydrogen electrode is 0. That's why I have not used that part here. So this entire part can be calculated as 0.059 into 5 with the negative sign. So it is something around 6 into 5, 30. So it is something around 0.2955 volt. This is the precise answer, but we can write that it is going to be 0.3 volt. Now on this side, what will happen? Once again, we have to use the similar formula. pH is equal to pKa. This is the 4 plus concentration of A and HA. Both is going to be 1. So it is 4 plus 0, that is going to be 4. So H positive will be 10 raised to power minus 4. Now apply the same formula here. This is for cathode. So E cathode is going to be once again ignoring the E naught cell because it is 0 for the hydrogen. It's a 0.059 with the negative sign. Here also negative sign, yeah. 0.059 by 1 log 10 raised to power minus 4. So it is 0.059 with negative sign multiplied by negative 4. So it is something around 6 4 is 24. So it is 0.23 something. Now put the value here. I need to find E naught cell. This is E cathode minus E anode. E cathode is 0.23 minus 0.29, which is 0.06 with negative sign. Minus 0.06. It's a minus 0.06. That is the right answer.